So the second section in Chapter 8 is about trigonometric ratios. So by the end of this lesson, you should be able to find the sine, cosine, and tangent of acute angles, and then use trig ratios to solve problems. So remember that if two right angles have one other angle in common, they're similar. This is the AA similarity theorem. So the right angle, these all have in common, and then they all have a 32-degree angle. So that means that triangle ABC, this big one down here, is similar to DEF, which is similar to XYZ here. So now that we know they're similar, we also know that their side lengths are proportional. So this one takes one of the legs, like the short leg, and that's proportional to the hypotenuse, which is the same as this short leg and this hypotenuse, which is the same as this short leg and this hypotenuse. These are things called trigonometric ratios. And a trigonometric ratio is just a ratio of two sides in a right triangle. And these are so special because they're right triangles. We spend an entire section on them, and there's actually an entire discipline of math called trigonometry that is spent talking about these ratios. So here's your definition. The first one is sine, S-I-N-E. The sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So if we focus on angle A here, the sine is the ratio of the opposite and the hypotenuse. So remember, ratio is just a fraction, opposite over hypotenuse. So S for sine, opposite over hypotenuse. The cosine of an angle is the ratio of the length of the leg adjacent to the angle and the length of the hypotenuse. So again, if we talk about angle A, it's a ratio of the adjacent side to the hypotenuse. So cosine is adjacent over hypotenuse. And then finally, the tangent, which we're going to get the most use out of in this class, is the ratio of the length of the opposite to the adjacent. So opposite over adjacent. And this is technically rise over run, which is pretty awesome. You're finding the slope here, which is the hypotenuse. So tangent is opposite over adjacent. So if you've ever heard of SOHCAHTOA, it's a little mnemonic that kind of helps you group things together. Sine is opposite over hypotenuse, so. Cosine is adjacent over hypotenuse, ka. And then tangent is opposite over adjacent, toa. SOHCAHTOA. It's also important to remember that we don't write these words out all the time. The abbreviation of sine is S-I-N, cosine is C-O-S, and tangent is T-A-N. So let's start off with some problems. Write the trigonometric ratio as a fraction and then as a decimal rounded to the nearest hundredth. So the sine of angle J, remember that sine is opposite over hypotenuse. So we look at angle J up here. The opposite side is 60, and the hypotenuse of my triangle is 61. So this is my ratio. The sine of J is just simply a ratio of these sides. We can leave it as a fraction, but it also told us to write it as a decimal and round to the nearest hundredth, which means 2 places. So this is about 0.98. Then we can do the same thing if we're looking for the cosine. So we're still talking about angle J here, but remember cosine is your adjacent side divided by the hypotenuse. So 11 over 61. So again, this is just a ratio. We could leave it like that, but they tell us to put it into a decimal. So this is about 0.18. And then finally, we got to find the tangent. And remember, tangent is opposite over adjacent. So opposite is 60 over the adjacent side, which is 11. And then if we divide this, we end up with 5.45. Now, one thing to notice about sine and cosine is both of our denominators here are the hypotenuse. Remember that hypotenuse is always the longest side, so these numbers always have to be between 0, and 1. They can't be less than 0 because they can't be negative because we're talking about side lengths here. And they can't be bigger than 1 because that would mean that one of your legs is bigger than your hypotenuse, which can't happen. Tangent, because it's opposite over adjacent and there's plenty of ways a triangle can look, this just needs to be greater than 0. It again can't be negative because we're talking about side lengths. So if you get something that is greater than 1 for sine or cosine, or a tangent that's negative, you made a mistake somewhere. So use a special right triangle to write the cosine of 30 degrees as a fraction. So think back to what you know about special triangles. In a 30, 60, 90, the short leg we can call S for a side. And remember the hypotenuse is twice this. And then this one is times the square root of 3. So if I want to write the cosine of 30 degrees as a fraction, I need to remember what cosine stands for. So cosine is adjacent over hypotenuse. So the adjacent side is whatever my side length is times the square root of 3. And my hypotenuse is 2 times whatever my side length is. Now because both of these have an s in them, they simplify to just the square root of 3 over 2. And now I know this doesn't seem important at all, and it probably won't be important until you get into Algebra 2 next year and into pre-calc. But this number right here, cosine of 30 degrees is the square root of 3 over 2, you will eventually have to memorize. All of this stuff kind of comes together in pre-calculus. So now we're going to go backwards. If I tell you the angle, you can tell me the ratio of the lengths of the sides. Now you can't exactly tell me what the side lengths are. Like if I tell you that something has a ratio of 0.5, your side lengths could be 2 over 4. Your side lengths could be 5 and 10. Your side lengths could be 50 and 100. All of these simplify to 0.5. So we don't know the exact side length, but we know their ratios. So you just need to type these into your calculator. And I want you to make sure that you can get the same answer as me, because if not, there's something wrong with your calculator. So the sine of 52 degrees should be 0.788, so let's say 0.79. Again, that's the ratio. So you could have a side length of like 79 and 100, and that would give it to you. Tangent of 65 degrees is 2.14, and cosine of 19 is 0.95. So again, make sure that you can type these in your calculator and get these numbers out. If you can't, you need to make sure you ask me about it in class the next day. This is super important. So let's do some problems. Find the length, round to the nearest hundredth. So I need to find BC right here. And they give me two pieces of information. They give me this side length, and they give me this angle here. So you have to stop and think about, in relationship to this angle, what two sides did they give me? They gave me the adjacent, and they gave me the opposite. So then think back to SOHCAHTOA. If they gave me the opposite and the adjacent, I can use tangent in order to figure out one of the sides that I don't have. So what I'm going to do is take the tangent of the angle, the 15 degrees that they give me, and I know that has to equal the ratio of the opposite side over the adjacent side, which I don't know, so we'll call it x. The tangent of 15, like we just proved, is just a number. So the tangent of 15, I got 0.2679. And now to find x, we can do some quick cross multiplication and some solving. And you end up dividing 10.2 by this 2.679. So you get the x is 38.07. So that's this length right here, 38.07. And you can check this because the ratio of these side lengths, opposite over adjacent, is 0.2679, and that's what we said the tangent of 15 degrees was. So remember, when you see this, the tangent of 15 degrees, and you plug that in your calculator, you're just getting a ratio. And it can be any mix of sides that end up with that ratio as long as they divide to get that. So let's do another one. I need to find QR. This is what I don't know here. So again, I look at the angle that I'm given and look at what parts they told me. So I definitely have the opposite side. And then this is the hypotenuse. So again, SOHCAHTOA, they tell me opposite and hypotenuse. So that means I'm going to use the sine function with opposite and hypotenuse. So remember, the sine of an angle is the ratio of the opposite over the hypotenuse. So then plug in what you know. The sine of 63 degrees is the opposite side, which I don't know, divided by the hypotenuse, which is 12.9. So the sine of 63, remember, is just a number. And then I'm going to multiply that by 12.9. And I end up with my opposite side has to be about 11.49 centimeters. And again, you can check this. You want the ratio of opposite over hypotenuse, so 11.49 over 12.9, to equal what the sine of 63 degrees is. So I get 0.89, and if I take the sine of 63, I get 0.89. So we check that we found the correct length. So you should be able to find the sine, cosine, tangent of acute angles, and then use them to solve problems like we just did. Make sure you write down any questions you have, and we can go over them in class. Have a good night.